And I'm David Crandall. I'm an associate professor here in the School of Informatics and Computing. And my main research interest is in computer vision. And so computer vision is, of course, the area of computer science that tries to get computers to be able to see the way that humans are able to. And so when I flash up an image like this, instantly, without even thinking about it, you start recognizing the objects in the scene, the buildings, the flowers, the people. You may identify what the people are doing. You might try to recognize them, maybe start inferring where this photo was taken, when it was taken, why it was taken, what's going to happen next. All these things that happen without even thinking about it. And at this point, for most of the last 50 years of a computer vision talk, we've had to now pause and apologize for why computer vision does not work nearly as well as, like, my dog at seeing the world, right? But recently, there's been some really exciting progress just within the last 3 or 4 years in this area, to the extent that in some problems like face detection, actually computers are outperforming or matching performance of humans on some tasks. The main reason for this is because of new technologies like deep learning, but really it's driven by the availability of big data, big visual data about the world on sources like Flickr and Facebook and so on. With all of this data comes both this opportunity of being able to train better models, but also the challenges of how to help people organize their huge collections of photos, like the literally nearly trillion photos that now are on Facebook's servers. So in my lab, we're interested in developing techniques to help people organize large-scale image collections. And I thought I'd give you kind of a whirlwind tour of some of the things that we're looking at and some of the things that we have looked at. For one, we're interested in core vision problems, like detecting people and their pose and objects, detecting their activities, classifying scenes, looking at object recognition, even really hard problems that are hard for humans, like recognizing particular species of birds. We're interested in how to organize large-scale collections of images through things like large-scale multimodal image clustering. We have a long-running project on visual geolocation, where we're trying to locate where on Earth a photo is taken, given the visual features of that photo alone, sometimes easy, sometimes quite hard. We work on 3D reconstruction, so given a collection of images of a place, try to infer a 3D structure of that scene from nothing but the images themselves. We're really excited about interdisciplinary collaborations. So for instance, with Professor Jeffrey Fox, we have a long-running collaboration on understanding large-scale data from the climate ice sheets, the polar ice sheets, to understand climate change. We have a new collaboration with the Crane Navy Base on understanding and analyzing collections of microelectronic images. And with Professors Chen Yu and Linda Smith here at IU, we've been using wearable cameras and vision techniques to better understand how children learn over time from their visual experience of interacting with the world. By the way, this thing about wearable cameras I'm really excited about. Wearable cameras, I think, are coming. Wearable cameras in the form of things like police cameras are already here, but in the form of other devices like GoPro and others, they're coming, and they're going to generate a brand new set of images that we're going to have to collect and think about how to organize. And so we're sort of been trying to get out in front of that trend, thinking about things like, what are the privacy implications of everybody wearing a camera? And how can we perhaps address those by using computer vision techniques that could detect private content and censor it or remove it, or at least alert its owner that it's there? We're also working on things like activity recognition in these wearable camera feeds, and just organizing and helping describe first-person and egocentric wearable camera images in general. So I started off this lightning talk by telling you that there's been some really exciting developments in computer vision and deep learning, and I thought I'd show you a couple of results. These are from a talk that we'll give, a paper that we'll present next month at a conference. And what I've done here is taken 6 images from my own wearable camera, and we developed an algorithm that can automatically produce captions for these images. And it uses deep learning techniques trained on millions of images, where you have images and sentences, and it tries to essentially translate an image into a sentence, something like that. So let me show you some results here. I'm typing on my laptop computer. I'm shopping at a store. I'm eating a plate of food with a salad and sandwich. I mean, these are really exciting. For someone who has spent 20 years trying to explain why our algorithms can't detect rectangles reliably, here we actually have meaningful captions coming up in these images. It's fantastic. It's amazing. It's progress. And then you wonder about this second row here. So let me show you some other examples. Okay, a teddy bear is sitting on a table next to a tree in a car. A spoon and big blue bowl of fruit sitting on a table with a laptop in the background. And my favorite, a man is holding a cat in his mouth. So you can see these things are learning very interesting properties of the world, but we don't understand yet exactly how they work, when they don't work. And so there's a lot of interesting research left to be done here. Underneath the hood of these techniques are some core technical themes like large-scale data, large-scale computation, machine learning, and deep learning, probabilistic graphical models, and so on. And with that, I'll conclude and just point you to our website if you're curious about more information, and also be around today to chat one-on-one. Thanks so much.